Hello, my math analysis lovelies. Happy Friday. After today, there are 20 school days left. So keep working hard or start working harder to get yourself caught up. All right, so yesterday we looked at arithmetic sequences. So today we're going to take a little glance at geometric sequences. So a geometric sequence is basically where you're multiplying by a rational number as you go from one term to the next. So you have a common multiplier, not a common difference. It's called the common ratio. So in order to find the common ratio of a geometric sequence, you simply take the higher term divided by the lower term. So you should be able to do it any place in the sequence since it is a common ratio. All right, so here I'm giving you a sequence, the common ratio. We have to find the common ratio, and we have to calculate the sixth term. You are going to need calculators for this, so you might want to pause and go get your calculator. All right, so to find the common ratio, I'm going to take the second term divided by the first term, and you need to leave these in fraction form. So if you reduce that, you get the common ratio of 3/2. So there's your common ratio. So since this sequence is given to you in fractions, then we need a fraction for our sixth term, not a decimal. Okay, so we can do this as term 1, 2, 3, 4. So I only need to find 2 more terms. So this would be called a sub 5 for the fifth term. So that's a sub 4 times 3/2. And you'll do that on your calculator. If you get a decimal, then you need to use your math key and change that back to a fraction. So it should be 841/4. Then to find a sub 6, we take the previous term, 841/4 times 3/2. Multiply, change it back to a fraction, and you get the sixth term as being 2,673/8. Okay, so all of this sequence and series stuff that we're going to be looking at is going to help you in calculus again when you do, it's called the Taylor series. I think there's like 8 or 9 different tests that you have to use for the Taylor series. And they're all related to sequences and series, arithmetic and geometric. Okay, so just like arithmetic, we had a formula, an explicit formula for arithmetic. This is your explicit formula for geometric. One thing you need to start doing as you're going through these notes is just have a separate sheet of paper that you can start writing some of these rules down on, because there's going to be quite a number of them that come up, especially as we start doing partial sums and infinite sums. So you should have one for arithmetic sequences, explicit formula, and for geometric, the explicit formula. All right, so for this one, we need to find the 12th term of this sequence. So I'm giving you 4, so we're going to have to go 8 terms out. So the easiest thing to do is figure out what the explicit formula is. So in order to do that, I need to figure out my common ratio. So if I take 1536 divided by 3072, I should get -1/2. Or -1/2. Okay, so that's my common ratio. The reason the ratio is negative is because you're alternating positive, negative terms. Okay, so now I can use my explicit formula to find a sub 12. That's equal to a sub 1 times my common ratio, which is -1/2, to the n-1 or the 12-1 power. So a sub 12 is equal to 3072 times negative 1/2 to the 11th. You can use your calculator for that. A little bit of common sense is going to tell you that the 12th term has to be negative because all of your even terms in the sequence are negative. Your sequence is also decreasing. So this is either a negative 1.5 or negative 3/2. So that one you could either have a fraction or a decimal because all of your numbers are integers in the sequence. Okay, so a couple more quick examples. Okay, so this one, the common ratio is 1/6. The third term is 18. So we need to find the first and the 7th terms. So we can use our explicit formula. I would have a sub 3 equals a sub 1 times the common ratio. And this would be 3 minus 1 since I'm giving the third term. So 18 is equal to a sub 1 times the common ratio, which is 1/6 squared. So 1/6 squared is 1/36. So I found my first term, a sub 1. If I multiply both sides by 36, I get 648. All this is manipulating formulas. Should be pretty used to that. Okay, so to find a sub 7, I now know my first term is 648, so there's a sub 1. My common ratio is 1/6. That was given to me. And then since I'm doing the 7th term, this is 7 minus 1. So a sub 7 is equal to 648 times 1/6 to the 6th. A sub 7 is going to be equal to 1/72. Okay, so the third term was 18. If you look at the first term is very large. So we're getting smaller as we go because we're taking 1/6 of the previous term. All right, so this last one, I give you the third and the 6th terms. The third is 1/4, and the 6th term is 2. So a sub 3 equals 1/4. A sub 6 equals 2. I need to determine the explicit rule. And I need to know the term number that this large number falls in place. So what term number is 2,097,152? Okay, so we did one similar to this yesterday. I'm going to drop these back and pretend like this is a sub 1. So that dropped back 2, so this would be a sub 4. So this is going to help me determine my common ratio. So I can do a sub 4 equals a sub 1 times the common ratio to the n minus 1. Okay, so a sub 4 is equal to 2. My pretend a sub 1 is 1/4. I don't know my common ratio, but I know this is 4 minus 1 or 3. So if I multiply both sides by 4, I get 8 equals r to the third. And if you just think about the cube root of 8, r is equal to 2. Okay, so now I can go back to my sequence and go back to a sub 3 and a sub 6. I know r is equal to 2. So I should be able to calculate my a sub 1, and then I'll have my explicit rule. Okay, so I can use either one of these. I'm going to use this one just because it's not a fraction. So this is a sub 6, so 2 equals, a sub 1 is my unknown. I know that 2 is my common ratio. And since this is the 6th term, this is going to be 6 minus 1 or 5. Okay, so I've got 2 equals a sub 1. 2 to the 5th is 32. So I get a sub 1 is equal to 2 over 32 or 1 over 16. Okay, so lastly, I know R is equal to 2. I know a sub 1 is equal to 1 over 16. And I know a sub n is equal to 2,097,152. So this n is what I'm calculating. So I've got 2,097,152 equals a sub 1 times my common ratio to the n minus 1 power. Okay, so I'm going to multiply both sides by 16. And I get 33,554,432 equals 2 to the n minus 1. And to solve an exponential, we use a logarithm. So log base 2 of 33,554,432 equals n minus 1. The value of n is always a positive integer because it's a term number in your sequence. So if you do log base 2 of that large number, you get 25 equals n minus 1. So n is equal to 26. So this large number is the 26th term. And there you go. All right, I have a worksheet for you today that kind of encompasses yesterday's arithmetic and today's geometric. Didn't take you terribly long. Remember, all you're doing is manipulating formulas, so make sure you have those formulas sitting in front of you. You guys have a wonderful weekend, and I will talk at you again on Monday.